Now let's take a look at the Infineon AURIX TC399 running AUTOSAR on all 6 cores in an SMP configuration. In winIDEA's new session configuration, we need to create a single application space for app all cores. Then we need to create a memory space for the SMP configuration and map app all cores to the memory space MS app all cores. Now we'll go to winIDEA 9.21. So now let's take a look at the Infineon AURIX TC399 in an SMP configuration. We'll create a new project for the TC399. We'll select our IC 5700 here. Now we select the device we're going to be connecting to, the TC399XE. Now we grab our ELF file as usual. So in this case we actually have a single ELF file for all 6 cores. Now we're going to make the additional configuration for the SMP and mapping the application space to the memory space. So we'll use the configuration that winIDEA created for us. Here we have a default application space. We'll go ahead and edit that, and we'll just call it app all cores. You can obviously name it whatever you want. We have our single ELF file here that programs all 6 cores. This is actually using an AUTOSAR, so that's what we should select here. And in this configuration we are using an iSystem XML, and we have our profiler instrumentation.xml file. Okay, that looks good. So that's the application space. Now we need to create the SMP configuration and the memory space and map the application to the memory space. So here we're going to select the SOC and edit that. We're going to go to SMP, add, and we're going to select all the cores that we have in our SMP configuration. So that's all 6 of the tri-core cores. We'll call it ms underscore app all cores. Now we need to go to the memory spaces. None of these are, so these are all the default configurations. We could leave these here if we want. That's fine, I guess. Or we can remove them. I'll go ahead and add the additional memory space that we need. We'll call it ms app all cores. Now we create it using the SMP configuration that we just set up, and then we map it to the application that we have, and that's all we need to do. That's the configuration for the 6-core SMP. We've got our single application, we've got our single memory space spanning all 6 cores. We don't need these other cores here. I'll just go ahead and remove them. Okay. In case we wanted the HSM, I guess we could have left that one back there. So we'll just add back HSM. And that's really the only 3 cores that are possible in this case. Okay. So that's good, and we have our program file. This is the file that we're actually programming. If we need to program additional files, S records, binary files, hex files, you can add them here. Now we just need to perform a download and get to debugging. Alright, so let's go ahead and perform a download here. Alright, so we're connected, sitting here at the start address. We're in CPU 0. We can see in SMP mode which core we're stopped in. So if we want to view the other cores, we have an SMP option here now. We can actually view the other core in this same instance, so just a single instance of winIDEA for all 6 cores. Let's go ahead and just run. Okay, so now I ran the whole system. Now CPU 4 is also running. You also have a process, so if we had different applications that we were debugging, we could select which process we want to debug. Let's take a brief look at the new analyzer configuration in winIDEA 9.21. Now the setup reflects the address and memory space mapping. We have a new process selection where we select which process we want to trace. I set up a trace for the SMP system using all 6 cores. We have a custom instrumentation to gather thread and runnable data from the OS for all 6 cores. We use an iSystem XML file with the TC399XE, which is an emulation device from Infineon that has a hardware trace interface. We're going to manually configure the hardware trace to record 2 variables over the Shared Resource Interconnect, or SRI. We have our system trace variable and our iSystem trace runnable variable. These variables provide runtime status of the 6 cores, threads, and runnables, which are the software components of the AURIX OS. We're using a 2-second limit session duration option. And then in the profiler section here, we're just selecting OS objects. And we have thread name and runnable name. These are specified in the iSystem.xml file. So the CPU is still running. We can go ahead and just start the trace. And so now the trace is sampling. It should sample for 2 seconds and then stop. And then we'll be able to view the results of the trace. And so just as always, you have your runnable data here in the code section, and then you have all of your task and ISR data in the lower data section. And then you can view anywhere in the timeline and zoom in to see what exactly was happening. And of course, you can right-click on any one of the runnables or tasks to get further information, timing on the specific number of calls that were made, the time it was spent, any nested calls, any interrupts, and the period data. And you get that for all runnables and tasks and ISRs. Thank you all for your time.